Alright, so here's our key for 6.3, and this is where we're going to talk about writing the equation from this graph and seeing what we can figure out. I can figure out that this graph has a vertical asymptote right at x is equal to 2. So when I look at my vertical asymptote at x is equal to 2, that means that came from x minus 2 as a value that led it to be equal to 0. So when I'm going to go ahead and build my equation, and remember every equation is y is equal to, I know that x minus 2 is in my denominator. Alright, let's talk about my numerator. When I look at my horizontal asymptote, I can go ahead and say, oh wait, it's not 0, 0. So I know that there must be an x in the numerator because here's a horizontal asymptote at y is equal to positive 1, which means there must have been a fraction here where I had an a over b that was equal to 1. So that means I know I at least have an x in my numerator. Alright, so here's my next part of the conversation. I know that that numerator had an input of negative 1 that gave an output equal to 0. So what I have to remember is my 0, if I had an input of negative 1, that meant that x plus some number was equal to 0 at that number, right? So if my x value that gave me a 1 was negative 1, what I'm looking for, that number here is going to be equal to 1. So your little box is equal to 1. Meaning if I put a 1 inside of here, this x value of negative 1 makes that a true conversation. So 1 is equal to 1. So x plus 1 is going to be the expression that's in my numerator for this fraction. X plus 1 over x minus 2, y is equal to. And then the next conversation is to go ahead and put that into our calculator and see if that matches. So when I go to y is equal to, I can go ahead and say x plus 1 divided by x minus 2 and recognize that that graph indeed crosses the axis and matches. And I can look at my table of values. Negative 1 going in is giving me an output of 0. So making sure we get this is important by using our intercepts. Okay, when we're talking about transformations of these functions, we also want to talk about all these possibilities that can happen. So if a is negative, that is going to give us a reflection over the x-axis. If a is bigger than 1, that's going to give us a stretch. If a is less than 1, that's always our compression. That's our conversation about a. When we start talking about h is going to determine our left-right conversation. So remember, when h is in with x and it's negative, it's going to shift the graph right. If it's positive, it's going to shift the graph left. When we have k, it's outside of where that x is, and that is the shift that is true to sine. All right, and here's our transformation of our equation. Our parent function, where we're talking about this, is a up in the numerator, the changes to x and the changes to k. All right, so we can look at each of these equations here and match it to the ones in the function box. So even if we're just having a conversation about vertical asymptotes, this equation is shifted left or right 3, which means it must have an x minus 3. This one is left 3, so there must be an x plus 3. And this one looks like it's also shifted 3 that way, so that's also a part of an x plus 3. So right away, I know that g of x is equal to 2 over x minus 3 for two reasons. This horizontal asymptote comes from this equation with 0 x's in the numerator and 1 x in the denominator. All right, so when I look here, I'm going to look at these asymptotes, and again, I don't see any x's in my numerators, but this minus 2 is going to make this whole graph shift down. So I know that h of x is going to be equal to 1 over x plus 3, and this is going to be minus 2, which leaves us with this equation, f of x is equal to negative 1 over x plus 3, and this negative 1 is what gives us that reflection where I have now quadrants 2 and 4 containing most of the graph instead of 1 and 3 like my positive graphs. Okay, let's talk about the reflections. So this graph is going to go to the left 3, and it's also going to go down 2. This graph's reflections, first of all, it's stretched by 2, and it moves to the right 3. And this graph here was a reflection, and it moves to the left 3. Okay, so here's the part of the notes that not everybody got to, so I want to make sure that we talk about these as clearly as we can. We have two different kinds of parent functions. Here's parent function A, and notice I have x to the first power. Parent function B has x squared. So it's interesting what you see that this square does. Any negative values that used to exist are now made positive by that exponent. So when x is in the denominator, that's when I get these curves. Some features that are interesting to talk about is 0 is still never going to be a value. They still have vertical and horizontal asymptotes, but all of these negative output values that are possible here when x is to the first power are made positive when x is squared. So when we look at 1, 2, 3, and 4, we can see that this parent function is going to be f of x is equal to 1 over x, as is this one, f of x is equal to 1 over x. This function has all these negative values becoming positive when they've been squared. So this one, f of x, 1 over x squared, and this f of x, 1 over x squared, all those negatives ended up reflecting back over the x-axis. All right. When we're graphing rational functions with two vertical asymptotes, these two vertical asymptotes are going to be the result of having a square in the denominator. So when we look at each of these, remember our first step is always, always, always enter it into the graphing calculator. So we're going to say x is divided by, make sure you have your parentheses, 2x squared minus 8. So when we go ahead and we graph that, the interesting thing that we see is these two vertical asymptotes. And we're wondering why that's a possibility. And when I take a careful look at this denominator, I can see that g of x with x in the numerator, this is a conversation that needs to be factored. So if I take 2 out, I wind up with x squared minus 4, which I know factors into x plus 2 and x minus 2, which means that I have 2 values that make my denominator equal to 0. So 2 times positive 2 and negative 2, my graph will zero out. When I look at my horizontal asymptote, I'm going to go ahead and have more x's in the denominator than the numerator, and whenever that ends up happening, I don't use my a over b. If I have more x's in the denominator, y is equal to 0 is going to be my horizontal asymptote. Now this is interesting, and it's nice to go to the table of values and get an idea for where your graph is going to wind up. And the most important thing is to look at values on either side of the asymptote. So when negative 3 goes in, negative 1/3 comes out. Negative 4 comes in, it's even smaller. When I have negative 2 go in, it's an error. When I have negative 1 go in, my value is going to be above the axis. 0, 0 is also a point, and then this point goes down below. Positive 2 is an error. Positive 3 is going to be equal to positive 1/3, and 4 is going to be equal to that value that's even closer to the axis. Now that's hard to know what's going on, so when we go back to the graph, I can see, okay, check out where this graph is. If this goes here, then this graph goes here, and then I have this coming down here, and this going here. Very interesting conversation when we talk about our asymptotes also. So now let's go back and look at this. When x is equal to 0, what happens? 0 comes out. But I thought that was an asymptote. That's an interesting conversation that we'll have and go over when we are together in class. Okay, let's talk about domain. So we have to make sure that our x values hop over our asymptotes. So we have our domain of negative infinity up to, but not including, negative 2, negative 2 up to, and not including positive 2, and then positive 2 up to and not including negative infinity. All right, so when we look at our range value, we're going to be starting down here at negative infinity. And while this graph hops over the asymptote and this graph picks it up, interesting part of this graph is that it can be a value through the whole way. So that means that 0 is included because it actually is our 0 and our y-intercept. So it's crazy how we get both the horizontal asymptote for these parts of the graph, but that still represents a valid point that I can have. All right, as x approaches negative infinity, this graph approaches 0. As x approaches positive infinity, this graph approaches 0. All right, so we'll talk about this graph. I have more x's in my bottom. So because I have more x's in my bottom, I know that y is equal to 0 is going to be an asymptote. My vertical asymptote is going to happen when my denominator is equal to 0. So I'm going to have to factor that. So I'll split my x's, and I'll have plus 3 and minus 1. So my vertical asymptotes are going to happen at where these can equal 0. So if I set x plus 3 is equal to 0, x is going to have the value of negative 3. If I set x minus 1 equal to 0, x will have the value of positive 1. So at negative 1, 2, 3 is going to be my first asymptote, and at positive 1 is going to be my other asymptote. So I can see the boundary markers for where these graphs are going to hit. Horizontal asymptote is going to be y is equal to 0. All right, so my domain is going to hop over those asymptotes. So negative infinity up to, but not including, negative 3, up to, but not including positive 1, up to positive infinity. My zeros are going to, and my y-intercept, I'm going to go ahead and put this graph into the calculator and see where that happens for me. So I'm going to go ahead and say 1 divided by parentheses, x to the second power, plus 2x minus 3. When I look at my graph, see if that fits what I had planned for my values. We'll go ahead and look at, it's important to look at points on either side of your asymptotes. So when I look at negative 5 over negative 5, I'm positive 1, 2, 3, 4, 5, but just barely. Negative 4, I'm positive but just barely. So I know that this part of the graph is going to go this way. Negative 3 is an error. Negative 2 is going to be negative and negative. 0 is going to be, and it's interesting when we see this is a little bit of a quadratic relationship where I have this curve that ends up happening like this. And when I have 0 go in, that negative 0.33333. So we'll put that in as my y-intercept. 0 goes in, and that's negative 1/3 that comes out. So we'll look here at there's my asymptote. 2 goes in and 0.2 comes out. And this gets even smaller. And this gets even smaller. So this value comes like that. And when I go back and look at my graph, I can see what that looks like there. When we talk about what our zeros are, there's never a time that this numerator is going to be equal to 0. So I'm going to say none. As x approaches negative infinity, my y values are going to approach 0 from both of those ends. All right. Come with questions tomorrow. We'll review and talk and practice, and then we'll take a little assessment on this.